Okay guys, in this video we really just want to talk about an extension of proving that triangles are congruent. And that extension is really just matching up corresponding parts after you've shown that two triangles are exactly the same. So the phrase is corresponding parts of congruent triangles are congruent, and this is the shortcut that we're going to use, CPCTC. So this acronym CPCTC is what we're going to refer to when we're more or less just saying, hey, I just proved that these two triangles are congruent, and so I'm going to match up corresponding parts and ultimately say that those corresponding parts are congruent. All right, an example is this one was actually off of your homework. So you proved that these two triangles are congruent, and I'll go over that in a second. But we're given some information here. We would mark that information on here, but notice the question has now changed. So the question has no longer become prove that these triangles are congruent. The question has become show that two of the pieces within these two triangles are congruent. All right, so that's a different question. Once you see a question like that, we still take the process of proving that the triangles are congruent. But ultimately, in the end, we want to show that angle A, which is up here, is congruent to angle D in this other triangle because they're corresponding parts and the triangles are congruent. So let's go through that process. I just want to show you this process in the end. All right, so here's a scenario. This is what we're looking at. Stuff kind of got thrown off here, but there we go. So we want to prove we want to show that angle A is congruent to angle D, and in order to do that, we actually need to prove that the triangles are congruent first. So you've done this in your homework already. I'll just run through the proof real quick. The proof is actually an SAS proof. So let's go ahead and start with the stuff that we need. The first thing we need is let the diagram be given. And that's true for any proof. So let's go ahead and lay this out. We need a side argument, and then an angle argument, and then another side argument. And I'll show you where those come from here in a second. So the first thing that we're going to look at is we're going to look at the given information. We know that AB is congruent to DC, so let's go ahead and use that information. AB congruent to DC. And that's given information. So our justification is that it's given. The next is the angle argument, and that angle is also given. That's right up here, ABC and DCB. So angle ABC is congruent to angle DCB. Plop my symbols in here. There's an angle. There's an angle. And I need a congruent sign. And we can say that, we can make that statement because, again, it's given. So that's given information. The last part here is our last side argument. And our last side argument is side BC, very simple argument. We know that BC is a shared side. So now we've gone through that proof. We've gone through and we've said, hey, I've proven that these two triangles are congruent. We need a therefore statement. So therefore, by the SAS shortcut, we know that triangle ABC is congruent to my congruent sign here, triangle DBC. Nope. DCB. So we showed that the two triangles are congruent, but keep in mind, remember, we're not necessarily trying to show that. What we're trying to show is that angle A is congruent to angle D. So angle A is up here. There's angle A. Here's angle D. Well, the whole point in proving that these two triangles are congruent is because we can then match up corresponding sides. And so because these two triangles are congruent, we can make the statement that by CPCTC, and this is the new stuff, by CPCTC, and again, what that means is corresponding parts in congruent triangles are congruent. We just showed that the two triangles are congruent, and what this is saying is I'm going to go ahead and match up corresponding parts. So we say we know that angle A is congruent to angle D. Angle A is congruent to angle D. And that's really all there is to it. So once we've shown, this is becoming a little bit annoying, but once we've shown that the two triangles are congruent, we can match up the corresponding parts and say, hey, I know that those corresponding parts are going to be congruent as well. And that's all there is to it. All right, so one more example for you guys. Again, this should look relatively familiar. And again, the question is prove that MP is congruent to QP, not necessarily that the two triangles are congruent. But the way that we get here is by proving that these two triangles are congruent. So let's go ahead and go through that proof. We always start with a let the diagram be given, a let statement. So there's our let statement. A couple different ways that you can prove this. We're going to do it by, let's say, angle, angle, side. So angle, angle, side. That's going to be our proof method. And there are a couple different methods that you can use, but this is the one that we're going to use for this particular one. All right, our first angle measure, or first angle argument is going to come from these parallel lines here. So we've got two lines that are parallel, RQ and MN, and we know that if we have two parallel lines and they're cut by a transversal, or just a line going through those two, that it creates a bunch of relationships. One of those relationships is if we have alternate interior angles, they've got to have the same measure. So those two, angle Q and angle M, are going to be alternate interior angles and therefore are congruent. So that's the argument that I'm going to give. Angle M is congruent to angle Q because alternate interior angles are congruent. So let's steal a couple of these signs over here. These symbols, angle M and angle Q, are congruent because we know alternate interior angles are congruent. All right, so that's my first angle argument. My second angle argument is going to be given. These two angles are congruent because they're both equal to 90 degrees, and that's the exact statement. So we have angle RPQ is congruent to NPM. And those are those 90-degree angles. They're really just equal to 90 degrees, and we can say that as well. So it's equal to 90, which is equal to angle NPM, and that's given information. So let me again plop my symbols in here. That's given information. My last argument here is going to be my side argument, and that's given information again from the diagram. So that is RP is congruent to NP and that's given in the diagram. All right, so we've got our argument. We proved it by AAS. We make that statement. So we've got a concluding statement here. Therefore, we know that triangle, and again, be careful when you name these triangles. They don't tell you which triangles you're trying to show are congruent, so we need to make sure that we name them in the correct order. In this particular case, we're looking at MNP, and we're saying that that is congruent to triangle QPR, and we showed that by AAS shortcut. Alright, so let me throw my symbols in here. Triangle MNP congruent to triangle QPR by AAS. And again, ultimately, this isn't necessarily what we're trying to show, although we do need to show it in order to get to where we're trying to get. What we're trying to get is, hey, can we match up corresponding parts? And so what we're trying to show is MP is congruent to QP. Here's MP. There's no real way to reason our way around that other than the fact that we just showed that these two triangles are exactly the same. And if we know that the triangles are congruent, we can use our CPCTC argument. Corresponding parts of congruent triangles are congruent. We showed the triangles are congruent, so we match up the corresponding parts, and those corresponding parts happen to be MP and QP. Those two are congruent. That's what we were trying to show, so we're done.